So today we're going to focus on the model view controller design pattern. We're going to do an example that goes through something that uses model view controller. So model view controller is something that's really big in iPhone development. The whole idea behind model view controller is that you've got objects that fit into each category. So you've got at the top the view layer objects. These are your labels, your buttons, your switches, your sliders, things that display information to the user and things that also get information from a user. So those are the view. And then at the back end you've got your model layer. These are the things that store the data that are responsible for persistence. And then the control layer is what communicates between them. We'll look at each in a little bit more depth. So the model view controller was actually covered in chapter 3 in the book. There is a little section in there about the model view controller focus that Apple uses with their development, and it's a good section. Make sure you've read that. So you should have read that a few days ago at this point. So the whole idea is that you've got your view objects. They send user actions to the controller. The controller uses those actions, it interprets them, and makes updates to the model. The model then changes the background data it tells the controller, and the controller uses that to update the views. Some quotes from the Coca Fundamentals Guide. That's where all this slideshow came from. In general, model view controller programs tend to have more reusable pieces, so the objects are more reusable. The interfaces are often better defined, and they're better at changing for requirements and future extensibility. A couple quotes there for how MVC might help. Just to kind of look at a few specifics for each of these model and then view and then controller. The model objects encapsulate the data. They're also the ones that are responsible for persistence. In this course we'll cover persistence once we get to some of the later chapters. I think it's like the 9, 10, 11 range. They have no connection to the interface. They have no idea what the interface looks like. The big thing they do is they have properties. They store these properties. They save states, things like that. Those are your model objects. They're kind of the back end. Your view objects are the front end. Those are how things look. Apple puts a lot of stock in how things look, right? And you as a developer should as well. So the view objects display information to the user, and then they also get information from the user. So like here are a bunch of view objects that are all UI controls. I guess labels just a subclass of UI view, but there are a bunch of examples of view objects. I think you get the idea there. For performance reasons, sometimes they do cache the data they display, but it's really the model who's going to do the persistence in the back end. But for performance reasons, they do store a little bit of information. And then, of course, the controller sits in the middle. One example of a controller is the app delegate. Other controllers that you use are the view controllers. Those are slightly emerged between two, but controllers are where you actually spend most of your time writing code, right? So you test a very reusable model, you test a very reusable view, and the controller makes all the links between it. So it's the intermediary, it's the conduit through which these things talk, and you're going to spend a lot of your time in the controller later writing a lot of code. Of course, you get objects that kind of combine roles. So you get some model controllers, which is kind of a merge between a model and a controller. So it's a controller that's directly responsible for a model object. And of course, you get view controllers. You use this one a ton. And so it's a controller that's concerned with one specific view layer. So it's a view controller. So we'll just summarize the theoretical, then we'll get into a demo. So you can combine roles, but in general you should try to make a clear separation between them. It helps make things more reusable, have less dependencies. The objects should be more reusable, especially the view and the model objects. So you could use a model object with all sorts of different views. Of course, it shouldn't depend on that at all. And the whole goal here is to kind of limit your dependencies for your objects. Greater dependency means less reusability. So if we can have less dependency, we get better reusability. So that's the theoretical summary. Let's do an example. Everybody learns by examples. It's just how things stick in your head. So what we're going to do is we're going to make a tic-tac-toe game. The images in this tic-tac-toe game were taken from the follow-up book to the one that we're using. It's in the More iPhone 3 development. They made a tic-tac-toe game to show off GameKit. We are borrowing all the images from that book. Since we used their first book, I assume they won't mind. So what we're going to do is we're going to have a model object called a tic-tac-toe game. It is going to store all the information for our game. So the model object needs to store what are the different marks on the board. Is it an X, is it an O, or is it blank? And that's really all the model would have to store. We choose to go ahead and let the model also store the game state. You could always back out the game state by looking at the board, but I go ahead and store it as well. So we've got a game state, and then these 9 locations on the board are stored in the model object. Since this class we haven't actually done a lot of Objective-C programming yet, I wrote the model object for you. So we will start by downloading my model object. It actually works out nice because then you can kind of see the division earlier in your programming efforts, since I've just written the model object for you. The view objects are going to be existing classes, so we're going to be using UI labels, UI buttons. So there are 9 buttons on the board, a 10th button with new game, and then this one's a label. There's also an image view, of course. And then the controller, we're just going to make a tic-tac-toe view controller, and it just links the two. So we'll kind of come back to this image as we're talking about things. Just to kind of quickly look at the model object that we're going to be working with. Here are the different things that the model object does. Looks like my image quality could be a little better. So it's going to store the game board. It's going to store a mark for every row and every column, so it's a 2D array. The marks can be either none, X, or O. So I just made a quick little enumerated type for what the different marks could be. So it keeps that. And then the game state could be X's turn, O's turn, X1, O1, or it's a tie. So those are the 5 game states. So I've got a variable that stores that. So the model just keeps the information to keep track of the game. It's a very simple model. The way that you get access to this information is the game state has a property, so it's publicly available, so you can just read the game state using the .game state. To get the information about the rows, there's a get mark in row where you give it a row and a column, and it just returns the mark. I could have just made the board have a property as well, but I thought it was a little better to do it this way. So that's how you get the information out. So that would be kind of like this notify line. That's how you get information out of the model. In order to update the model, you need to be able to tell it information. The things you have to tell it is you just have to tell it that the player pressed a row and a column. If you tell it where they pressed, it does everything else. So you just tell it where somebody pressed. If there's a piece there, it'll be smart enough to do nothing. If there's not a piece there, it'll know to put it there. It'll update the state. And so that's what that's all about. The other thing you need to be able to do is you might need to reset the game. So if somebody hits reset game, that's going to be how you communicate that information to the model. So 2 methods to update, 2 methods to notify. That's how we're going to connect the model to the controller. Model knows nothing about the view, right? So it's just these guys talk right here. And then we'll set up the connections on this side using things we're pretty familiar with. So the actions and the outlets, so things you've been doing for a while. So let's go ahead and download this information. So you can download it by going to Lab 1, and you can go ahead and download stuff for Tic-Tac-Toe. So if you click on this download link, It should take you to a download page, and you can play around with this download to enjoy the fun. Once you've got it downloaded, just double click to extract the zip. Obviously I've done this a few times. Things that you can see that are in this file, there's the board image, the icon for the iPad, the icon for an iPhone, the X's and the O's, the new game button, and then these two are probably the most important. This is the model object. So right now this is sitting in my downloads folder, but once I make a project I'm going to bring these things in. So let's go ahead and make a new project in Xcode. So for the lab, what you're going to need to do is you're going to need to make a universal app that works for iPad or iPhone. But what we're going to do is we're going to do just for the iPhone. We're going to do a view-based application that saves us some of the clicking and linking, hopefully that you're pretty comfortable with by now. But for this example, I'm just going to do a view-based application for the iPhone. So I'm going to have to give this a name. I'm going to go ahead and call it Tic-Tac-Toe. Obviously I've done this once because I did it in class, so I'm going to have to call mine Tic-Tac-Toe Video. So once we make this new project, the first thing I want to do is I want to bring in those resources. So what I'm going to do is I'm going to bring in the images first. So I'm going to click on Resources, Add Existing File. I'm going to go get, from my Downloads folder, let's see which ones were the latest ones that I grabbed. I'm going to come in here and I'm going to grab just the images, so I don't want to grab these two yet just because I want them to get organized into a folder better. And then since my example is iPhone only, I'm actually going to not even include this PNG. There's no harm if you include it if you want to bring it in. I'm going to go ahead and copy them in because I want to bring them out of my downloads folder, and I want to put them into my folder. That's actually very important, by the way, because if you put something on the App Store, it only grabs what's in the folder. So we're getting set up. Let's go ahead and bring in that model object. So bring in an existing file. And so we just want to bring in these two. So the two model objects, Tic-Tac-Toe game. And copy those in as well. Great. So now we've got a lot of good things going. You can see that we've got a completely finished model object. You can assume that I made it to where it works. I tried to test it. By the way, we'll be having you make a model object for Connect 4 in a later lab. I can't say Connect 4 because that's trademark, but I can say 4 in a row. So we're going to make a 4 in a row game, and you're going to make the model object for that. So I took the fun away from you on model object creation here, but don't worry, you'll get your chance. Cool, so let's go ahead and get started. Often one of the funnest ways to get started is to start with changing the zip file. So let's go in and set up some things in our zip file to get this Tic-Tac-Toe game underway. So now what we're doing is we're working on the view side. So let's start dragging some things into this view. The first thing that I want to go ahead and grab is I'm going to go ahead and put an image on here. It should automatically go to the full size of the screen. I'm going to hit Command 1 to bring up the the first attributes window, and I'm going to make it be the board image. The board image was already properly sized. The guys who wrote the book did that, so that was really handy. Next, to make it start looking like something, is we're going to go ahead and put in a button. And this button, previously we've always used round rect buttons, but this one's going to be a custom button. And it's going to have an image property of wood button. You notice that the size is all wrong at first. One of the things you can do is you can click on size to fit. This is also the shortcut key Command equals. And you'll see that they've done a really nice job of making it already the correct size. So snap it in to the blue guidelines so that you can follow the HIG. And now we've got a button. Next, let's go ahead and add our label. So the label I'll go ahead and put on here right below the button. I'll just let it stretch from side to side and center it up. And you can change the font size to something that's a little bit more visible if you like. I'll go with 24, that looks about right. Doesn't matter what it says here. We're going to be overwriting it in code. I'm just going to type user message for now. You can make the color something pretty if you like. I'm just going to leave the default. I guess you could goof around with some of the obvious colors here. Dark gray color, I think that looks worse. Light gray color I think looks worse. I'll just stick with black. Cool. So the next thing we want to do is we've got our button here, we've got our label here. We actually want 9 different buttons for each game square. So what I'm going to do is I'm going to start making some buttons. So I'm going to say UIB and drag over a button. When you're sizing the button, we actually want the button to be the same size as the image. If we look at these images, they're actually 86 by 98. So I'm going to make my buttons the exact same size. So I'm going to make my buttons 86 by 98. Cool. So that's how big I want to make my button. They're already sized that you should be able to put it on the board fairly easily. Eventually we're going to make these buttons be custom buttons. So they're going to kind of have a transparent look to them. But for now, I'm going to make them nice and visible. So try to spread them out such that they're on the game board in appropriate places. The trick that I'm using here to copy is I'm selecting various things, I'm holding down the Option key, and then I can drag them over a little bit faster. And so you can try to get it, just to your liking. That looks pretty good to me. A trick that we're going to use this time, instead of making an outlet for each button, which starts to get a little tedious, we're going to use tags. The tags we're going to set on these, what we're going to do is we're going to start off with 1,000. Instead of starting with 0, there's always a risk that Apple might have a view with a tag 0. They do a pretty good job of avoiding it, but there's a recommendation somewhere where you start off at some big number. Really, it's just important that you avoid, like, I don't know, the 0 through 5. The only things I've seen that even use tags are, let's see here, I think the UI alert view buttons use tags, but there really aren't many. So this is going to be tag 1000, and what I'm going to do here is I'm going to use the ones place to indicate what column something is in, and I'm going to use the tens place to indicate what row something is in. So the button that's right below it, it's going to be 1010, so it's in row 1, column 0. So this is row 0, row 1, row 2, likewise column 0, column 1, column 2. So we'll go ahead and go through here and label the rest of our buttons. Now we've got row 0, column 1, row 1, column 1, 2, 1, 0, column 2, 1, column 2, and then 2, column 2. Cool, so now they should all have a tag on them. You should be able to go through and check to kind of like make sure that the tags make sense. They should be in a nice sequential order in each row. Should feel pretty comfortable that those are okay. And then the next thing we want to do is we want to make them all become custom buttons. So we'll go ahead and make them custom now. When they go custom, they kind of go invisible. This app is a really good example of using standard controls, like these are just buttons and labels, but when you make the buttons images, they don't feel like buttons anymore, right? I mean, they feel like a custom thing that's built in. So I mean, this is something that's really nice that you can do with images. One thing I'll warn you about though is this new game button. It looks really sharp, but having text inside an image makes it much harder to translate your app into different languages. So that's one thing to consider, is that sometimes text inside an image makes translation more annoying. You can do it, you just have to make a different image for each language. Whereas if it's just a label, there are a lot of tricks you can use. Cool, so we started off the view. The next thing we have to do is we have to make some outlets and actions. So we're going to need an action for pressing reset and an action for pressing a game board. We're going to make these all call the same function. Then we'll use the tag to differentiate. We're also going to need an outlet to the label. So let's go do that. So inside our Tic-Tac-Toe view controller, we're going to have to make a label outlet. So I'll just call it user message label. And I'll go ahead and make a property for it. Standard non-atomic retain IB outlet. And then in terms of the action, we're going to make a pressed reset, and we're also going to make a IB action for pressing a board square. My names are not necessarily overly clever, but they mean enough to me to get the job done. Cool, while I'm here in text, I'll go ahead and do some other things. I'll go ahead and make these outlets in my implementation file. And then one of the things that I like to do just whenever I'm first hooking things up is I like to have it print a little message for me. The message that I usually print is I just print out what function it's in. And I just use those to make sure I connect things just kind of when I'm getting going. __ function, this is one we've used previously. It's a special built-in thing that returns a C string of whatever function you're in. I'll go ahead and also do my synthesize of my property. And then I'll be a good memory management citizen. I will release it when the view controller is deallocated. And also, if we run into a memory management situation where the system wants to dump my view, I'll say feel free to dump my label as well, because it'll get remade. So we've got all 5 places of putting in the properties. And then, because I know I won't use it, I'm going to go ahead and blow away the init with nib name and load view. We do things from nibs, so we're just going to blow those away. Should auto rotate, I'll leave the default, but I'll leave it in there. And view did load, we're going to play with that one later. Cool, so let's go ahead and connect some of these things to the zip file. Where'd my zip go? Right there. So what I want to do is I want to drag from files owner to the label. So now I've got a connection to the label. And then I'm going to drag from touch up inside to the pressed reset. And then for all of these guys, I'm going to connect them to pressed board square. So there's 1, 2. I think you get the idea here. I'll just pause it. Cool, so I paused it, but I connected them all. Here I'm connecting the very last one. Great, so from files owner, you should be able to click on the connections. You should see that there are a bunch of connections to the board square. Looks like I missed one because I've got 1, 2, 3, 4, 5, 6, 7, and 8. Pretty obviously I missed this one. Pressed board square. Alright, so let's try that again. So now I've got those guys there. My reset button is connected there, and my label is connected there. Pretty handy little trick how you can see what all is connected from the files owner. So save him up, close him down, and let's see if we've done anything useful. So I'm going to go ahead and click build and run in the simulator. I'm going to bring up my debug window, and I'm just going to make sure that things are connected in a happy-go-lucky way. So if I press reset, I can see that it calls that function, and then each of my buttons calls that function. Cool, so things are going good. Next thing we want to do is we were showing you this tag feature. Let's go ahead and do a little bit more in this area. So let's just go ahead and say pressed row %d column %d, and we're going to go ahead and print out the row clicked and the column clicked. Obviously these don't exist yet, so our goal is to make them. So what we're going to do here is we're going to the sender is the button that was clicked. So I'm going to set it equal to sender. Pretty sure this is not required, but I kind of like to typecast it as a button before I set it to a button pointer. I don't think you have to, but I like to. So a sender is a button. So button has a property called tag. So if we want to see information about button, I'm going to hold down Option and double click on it. Then I'm going to click on the doc file. And you can see that it's got a property. Oh, it's not actually on button, it's actually on view. So UI view. One nice thing about inheritance is you don't have to write things in multiple places. One annoying thing is whenever you're looking things up in help, you don't know if it was in this one or it's superclass. So there's a property called tag, and it is an NS integer. So I'm going to say NS integer tag of button. So we just want to say button clicked dot tag, and so that'll get us the tag for the button. Obviously we don't have to do this many lines of code, but I just want to make it very clear what I'm trying to do here. So now we've got a tag, and what I want to pull off of this is I want to pull off the row clicked, and the row clicked is the button of tag. There's a lot of ways to grab the tens digit. The way I'm going to do it is I'm going to divide by 10. So let's say it was 1020. Dividing by 10 would make it 102, and then I'm going to do a modulus with 10. There's probably some slick Objective-C function out there to do it as well, but that works just fine. And then for the column clicked, very similar task, except for I don't need to divide by 10. I'll just do a modulus with 10, and that'll give me the ones digit. So at this point it should say which button was clicked. So it should say the row and column number. So if I click this one, it should say 0, 0, 1, 2, and so I mean in this way you can feel really confident that you've got your tags correct. Cool, so now we know exactly who clicked each item, so that's great. The next thing we want to do is we want to start doing updates. So what we're going to do is we're going to make a private function just called simply update view. And so update view, what it's doing is it's just it's doing this path, right? So it is taking information from the model, and it's just going to be doing this update view. So you're going to be seeing this path is our underscore update view. So the things that we want to do in update view is we want to update the user message label, and then we're going to update all the marks in the game board. So let's go ahead and do the user message label first. It's the easier of the two. So in order to update the label, what we're going to need to do is we're going to need to get the state of the game. Before we can get the state of the game, it would probably be a good idea to make a game object. Making a class doesn't do anything, right? It gives you the ability to make instances. So let's go ahead and make a game instance. since I'm probably going to need it in multiple places, it probably makes sense to go ahead and make an iVar out of it. So I'm going to go ahead and make a tic-tac-toe game, which I'll just call game. Since I'm going to make something of this class, I need to tell the compiler, hey, this class exists, don't throw any warnings. And then next I can choose to make a property for it or not. To be honest, this one I could probably survive without a property, but I'm going to go ahead and make it. Makes memory management a little bit easier, and I want to teach you good practice. So we're going to make a property, and then we're going to synthesize the property. And then, since it was a retained property, we need to release it. And since we can make it again if the view goes away, I'll go ahead and let it go, and the view did unload. And where I'm going to make it is I'm going to make it inside the view did load. So this is the area that happens when the view loads. Just to kind of show you a style, I'm going to show you the style that the book uses. And that is they make a new object. It's almost easier to do and then describe. So they alloc and init it. They store that to a pointer called new game. And then they use the property to assign it to game. If you're keeping track of the memory management, when you alloc it as a retain count of 1, when you assign it using this dot self dot property, it's actually up to a retain count of 2, and then they take new game and they release it. It's a style which is fairly foolproof, which is kind of nice. So this kind of, you make it on a separate line. People who have programmed for a while, they do this kind of stuff in one line, and they may or may not use a property, but let's teach you good practice. And then within view did load, the first thing we want to do is we want to update the view. So we want to update the view to whatever is the current game state. Cool. So we're starting to write a lot of code, but hopefully we'll test it here in a little bit. So let's go ahead and go into update view, and let's see if we can make something happen. So what we want to do is we want to see what game state we're in. So we're in one of these game states, and then we're going to make a message based on that state. So what I want to do is I just want to make a switch statement based on the game's game state. And just to kind of help with the copy paste effort, these are the different switch case statements we're going to want. So we're going to want one for each of these. So I kind of like to just temporarily paste it on just so that I can stick it into the individual case statements. And for each one, I'm going to set the user message labels text to some string. So in this state, it is X's turn. One thing I showed in class that we'll get to later, when you get to chapter 17 in the book, you'll start to learn about localized string. NS localized, is it localized string? Yeah, it is. So there is a macro that helps you with localizations, just because I've talked about localizations. It's called NS localized string. What it is it's the key for the object that needs to be translated, and then a description of that key. Usually when it's short, you just write the same thing twice. We'll talk about how to actually use this to cause translations later. But if you want to get in the habit of anything that's going to appear on the screen, set up one of these NS localized string macros, and later it'll turn out to be handy. So do that if you like, not really required, but just kind of giving you a heads up. So we're going to need O's turn, X win, O win, and tie. So you can just kind of bring each of these in here. And then for each one, you want to make an appropriate message. and so you can change each of these to an appropriate message. Cool, so I just kind of paused it and I updated my message. I kind of regretted showing you the NS localized screen because then I kind of had to type everything twice. And we're not going to localize this app anyway, so oh well, there it is, you learn. Cool, so at this point what we should be able to do is we should be able to see the initial message change based on the initial game state. So if you run it at this point, it threw us a bunch of errors. I didn't import the Tic-Tac-Toe game. There we go. So now it should start off and it should say X's turn. Clicking on these doesn't do anything yet. We're about to change that though. And so a really easy thing, so right now we're updating part of the view, we're updating the label, but there's user actions, but the controller isn't actually updating the model yet. This is actually a pretty easy step. So when you press reset, what we want to do is we want to call on self.game, we want to call reset board, and then we will update the view. So at that point, for the reset button, we've added the update to the model, and then here instead of notify, we're actually just querying the model for its information, and then we're going to use that to update the view. On the pressed game state, or in the pressed game square, what we want to do is we want to say self.game pressed, I think I called it player pressed, there we go, player pressed row, and I can say what row was clicked, and then I can say what column was clicked. So I send that information to the model, and then I'm going to ask him, and then I'm going to update the view based on asking him questions about the model. So I'm going to send him information, and then I'm going to update the view. Cool. So at this point, we're sending information to the model, and we're updating the view's label. We're not updating the board just yet. But if you run it, you can actually see that if you click here, the model changed, and it said it's now O's turn. So if you would like, you can play invisible tic-tac-toe, so there's an X there, and then I'm going to put an O here. Now I'm going to put an X in the middle, then I'm going to put an O up here. Now if I put an X right here, X should win the game. And he did, which is cool. You can click on reset game, and you can play a new game. I'll have O win this invisible game. O wins. So you can play invisible tic-tac-toe at this point. I think this stage actually is a really clear one that shows how the different ones are separate, right? So I mean, we've got a complete model, we've got a controller which is doing most of it, a view which is all set up. The only thing we're missing is we're missing part of the update, right? So you could play a game like this, but if we added a view update for these buttons, it'd be a lot more fun. So let's go ahead and make that happen. So what we want to do is we want to update all the marks on the game board. To show you the basics of what we're trying to do, what we're going to be doing is we're going to be updating all the different buttons just to go ahead and get some practice seeing how this code works. So we're going to say current button. We're going to be using a function called view with tag. So let's say we wanted to find that middle button. So if we wanted to find that middle button, currently I'm just hard coding it so we can see what's going to happen. I'm going to use the view with tag. I knew that that existed because I've been looking around in UI view for different task, and it's one that I knew existed, right? So it's view with tag. It's in here somewhere. And so what I'm going to do with that button is I'm going to update that button's image. So with buttons, what you typically do with buttons is instead of just setting the property, you typically say set whatever the property is for a current state. You don't have to do it, but in general with buttons you always set something for a given state. So the image that I'm going to put on here, I'm going to show you a convenience method called image named. Image named is really handy. So I'm going to say put on here an image named x.png. For the control state, there are a lot of control states. If you start typing control state, you can see a list of the options. We're going to set it for control state normal. Control state normal is nice because if you don't set one of the other states, it will default to using control state normal. So at this point, that middle square should become an X. Cool, so it became an X. One thing it said it was mad about, view with tag, it actually returns a view. So what I'm going to do is I'm just going to typecast it as a button. I know that it's a button. So there you go, I typecast you as a button. So when we ran this, the middle square became an X. So what we're going to be doing is we're going to be looping through all of the different possible locations, and we're going to be setting their image, but instead of hard coding what we set their image to, we're going to be looking at the model object to see how to set it. Another thing we're going to do is this convenience method, UI image, it actually creates a new UI image object every time you call it, and there's no reason for that. So what we're going to do is we're going to make a property so that we only have to make it once. So we're going to have a property called xImage and one called OImage. To help me with my memory management, I'm going to go ahead and make a property for them. So standard non-atomic retain properties. And then since I made a property, I got to do all the other steps. So I've got to synthesize it. So it synthesized my X image and my O image. My memory management. And then since I can easily get these things back, if the view needs to get removed, I can go ahead and view did unload. Set them to nil. As long as I didn't make a copy paste error, that should be all set. Now what I want to do is I want to use this convenience method to set that property. I'm just going to go ahead and set it inside view did load. So I'm going to say I've got an X image. So I'm going to say self.ximage so that I use my synthesized property. And I'm going to set it to image name. If you're keeping track of memory management, when it gets created, it has a retain count of 1. Since it is a class convenience method, you know that it's in the auto release pool. So it's 1 when it's created. On this same line, I used the retain property. So this actually brought its retain count up to 2 once I used this property on it, because it's now held by this view controller. So it's up to 2, and then when the auto release pool goes away, it'll drop back down to 1. So this one should be all set. So we've got an X image and an O image. Cool. So what I want to do here is, well, let's just do a quick test to make sure it's up and working. So I'm just going to say set image to O image. Then I'm going to run it. I'm going to make sure it shows up as an O. Cool. So I tested that O works. I also tested that my IVAR works. Great. Now what I'd like to do is I'd like to iterate over all the different rows and all the different columns. So I'm just going to make a quick little variable called row, and row is going to go up until it's less than num rows. I happen to know that this existed in the model object, so it defined the number of rows. And I'm just going to go row plus plus, and then inside here I'm just going to do call. Sometimes I get too lazy to type column. That's when you know you're really a lazy individual. And then what I'm going to do inside here is I'm going to do these two tasks. So right now what it's doing is it's looking for this tag all the time. We don't really want to do that though. We'd like to look for a specific tag. So I'm going to say tag to modify, and that tag is 1000 plus 10 times row plus call. And so the tag that I'm interested in is the tag to modify, so that'll give me that button. I'll set the state for that button. So if my for loops work, right now I should set all the buttons to O's. Great, so I set all the buttons to O's. That's super. Obviously I don't want to set them all to O because I want to use the model object. So inside here I want to use the model object to determine how to set the row, set the image for the button. So the model object has a getMarkInRow method, so I'm going to use that, and it can be one of three states. So I'm going to go ahead and use a switch statement again. So I'm going to say self.game getMarkInRow, so I want row, and I want column call. It might return, I'm going pretty fast, but it's because it's a video. You can always pause the video if you need to. It's going to return a tic-tac-toe mark. The tic-tac-toe marks can be one of these three options. Let's go ahead and paste them right on here so that I know what all my options can be. So if it's none, what I want to do is I want to set the button's image to nil. Nil will just make it be transparent blank, which is kind of nice. I'll make a case for the other two. If it's X or if it's O. If it's O, I want to set its image to O. And if it's X, I want to set its image to X. Then I can get rid of my fodder down there. Cool. So at this point, we're looking at the model object to update the images on the buttons. Pretty simple code, but it's going to make a dramatic difference in our app when we run it. So if we say build and run now, we should have a tic-tac-toe game. So it's X's turn. X is going to click here. You can see that the update went through and it figured out how to update each person. Put O there, put X here. Classic little trap for O there. And then if X wins, it looks like we've got a winner in tic-tac-toe. So I mean, you can play tic-tac-toe to your heart's content. You should have a nice little piece of software for playing tic-tac-toe. Hopefully you have more fun making the game than playing the game. Pretty simple little game. With these images, it's pretty slick though. So you've made something that's like, borderline useful, that you could, play a game. And hopefully you've learned a lot about how the model view controller interacts. This was a really good example for keeping a really clean model, some really clean view objects with the buttons and labels, and then of course a single view controller. So your assignment for the lab is to make both an iPhone and an iPad version. This will just get you some more practice making universal apps. Not necessarily the greatest image sizes for the iPad, but I want you to practice making universal apps. So that's part of your Lab 1 assignment. Cool. Hopefully you learn a lot from this one and like this example as much as me. See you next time.